Hello, everyone. Thank you for coming. So we're the Enterprise API team, and we're here to talk to you about using Salesforce APIs at scale. I'm Iman Barkadarian.
I'm Leo Zamskov.
And let's get to it. So before we begin, you're probably all familiar with this. Just got to say it again. We're going to be talking about a lot of different APIs and features that are generally available and some that are currently in development and in pilot. And we stress that whatever business decisions you make, purchasing decisions, please make it on the features that are generally available. And we'll talk about which ones are in pilot and in development as well. All right, a little bit about what we're going to be talking about today. First, we're going to take a quick review of some of our data APIs. We're going to be talking about the problem of scale and when you use certain APIs. We're going to talk about bulk API and specifically a new flavor of the API, query in version 2.0. We're going to have a demo of it, showcasing a little bit of what it does and the developer experience. Then we're going to go to mass operations. Leo will take that away, and we'll talk about what we're doing there. We'll demo that one. And then we'll talk about what's next, what's on the horizon, and then we'll have time for Q&A. So in this day and age, every customer's connected. We got so many devices and technologies that are talking and communicating with one another. They're always on. They're always listening. Data is being exchanged with one another. We got fitness trackers and wearable devices, Amazon Alexa, smart home, all listening and exchanging data. And with that, our customers and your customers have an expectation that comes with that. One of a seamless experience where all these services talk and communicate. Uber is an excellent example of this. It really has a seamless experience that we all know and love, but behind the scenes, there's a number of different services that are getting involved and communicating with one another. We obviously got geolocation data. We got customer data. We have API services that are sending information back and forth. We got billing. But the thing is, the end user doesn't care about that stuff. They just have a simple experience, and all these different services are communicating with one another to provide that. So at the heart of the integration is the APIs. And here at Salesforce, we want to show you we provide the same seamless experience and value for ingesting data into your organization and extracting that out. Over here, there's a number of different APIs we're talking about, and this is only a selection of them. But primarily, us in the platform and the data APIs, we want to focus on the left side. The left side is our data APIs, and we're going to get more into what each one means. The SOAP APIs, for example, we're going to be sending data using standard SOAP XML messages. REST APIs, we're going to be manipulating data using a RESTful design pattern and sending JSON and XML over the wire. And both of these are synchronous APIs. And then we're going to be talking about bulk APIs, which is an asynchronous API that allows us to insert and extract data at much larger volume. All right, so let's talk about scaling APIs. Before we begin, let's just talk about the two natures of requests. We have synchronous and asynchronous requests. So synchronous requests, for those that don't know, a client sends a request to a server, and they're blocked until the server decides it's ready to send a response over. And so primarily because of that nature, you're going to be working with smaller records at a time. Exactly. So with asynchronous requests, the client is going to send a request to the server and continue on doing whatever it needs. It's not blocked. And when the server's ready, it'll send a response back to the client. And so because of that, and you're able to keep doing your work, you don't care how long that operation takes, so you can generally use that with much larger data volumes. Now let's talk about different examples of both in the data APIs we were mentioning before. So SOAP API, Simple Object Access Protocol. This is an API that allows you to create, read, update, and delete records in your Salesforce org. And how it operates is with this notion of a WSDL, a Web Services Description Language. It is an XML hard-defined contract between the client and the server. And so when you have a WSDL, it represents exactly what the server is expecting the client to send over, what's valid and invalid request. And so that's in XML only. You can authenticate with the SOAP login call. OAuth 2.0 tokens work as well, but that is the recommended approach. It's once again a synchronous API, and because of that, you're blocked, and you can work with up to 200 records at a time. Oftentimes we say this is well suited for system integrations and legacy systems where two systems are communicating with one another because of that locked-in time contract that I was mentioning before, the WSDL. Now we're talking about REST APIs, representational state transfer. This also allows you to create, read, update, and delete records in your Salesforce organization, but there's no WSDL anymore. There's no hard contract. We're sending over standard HTTP requests, and you can send XML and JSON over the wire. Now, you can also authenticate with a SOAP login call, but since we're now moving toward REST, a more modern API design, we prefer that you authenticate with an OAuth 2.0 token. SOAP works as well, though. It's another synchronous API, but in this case, REST is primarily oriented around operations on a single record at a time, not the 200 records I was talking about with SOAP, with the exception of composite APIs that Leo will talk about later in the presentation. And so because of that, it's more well-suited for mobile applications and browsers that don't need to access high amounts of data at a time. And finally, bulk API, or asynchronous family of APIs. Because of this, its asynchronous nature, we can work with many, many more records at a time, and you don't have to be worried about getting blocked for a response. We're talking millions of records. And so this is another RESTful API for large-scale data. We have version 1 that's been GA for a long time, and recently we've went GA with version 2 for ingest, and we're adding query support as well, which we'll talk about in this presentation. Once again, you can authenticate with the SOAP login call or OAuth 2.0 tokens. And with that, let's actually get a little more familiar with bulk API. So over here is kind of the shape of the bulk API experience. It's asynchronous in nature, so we have this component known as a job. This job defines what type of operation you want to do, what object you're performing it on, and what's the content type of the operation. Also on top of that, you have to upload a batch, and this batch is like a unit of work. And based on how large that asynchronous job could be, you could have one or more batches. And once you upload that batch, you're going to have to close the job so that you can kick off the asynchronous process. And after that, when the job's complete, you're going to keep polling for the state of the job, or the batches actually, the individual batch states. When they're all complete, you can go ahead and retrieve the result sets. And each batch can have one or more result sets. So that is the general experience of the bulk API. But as you can see, the notion of batch and result sets has been exposed to the client. And oftentimes when you want to retrieve data, no, all the time, the onus falls on you to go ahead and make those requests and aggregate the results. So we've recently went GA with bulk API version 2. And with that, we've wanted to take away the notion of batches and result sets from you guys. Because honestly, we know how to manage our resources better. And so you guys don't have to deal with it. You should just upload a single file, we'll batch it internally, and then we'll give you a single result endpoint. That's the biggest. So with bulk version 2, we're primarily focused on the same experience and the same functionality, but a simpler user experience on your guys' end. Additionally, it's going to be built within our standard REST framework. If anyone's integrated with bulk version 1, you notice it's in a separate servlet. And with that, with being in a standard REST framework, we'll talk later about all the benefits that come with that. Limiting also will be changed. The notion of batches I was mentioning earlier, these like units of work, that's how we limited, that's how we metered customers. And so different batches could have different amounts of data in them, but since they're measured equally, one batch regardless. Now we're going to be talking about number of rows processed, something more understandable for the client end. And bulk version 1 supports CRUD, create, read, update, delete, but version 2, we are now in pilot stage of query 2.0 as well. And we'll be talking about that in the next slide. And also, currently we only support parallel processing in version 2, but we're moving toward the direction where we can put the two in parity. Alrighty, so let's actually take a deeper dive into query specifically and the experience that comes with that. So I mentioned this notion of creating a job, uploading these different batches. This is the experience of version 1. And so you're going to upload these batches, you're going to close the job and keep polling the status of that job. And then eventually you're going to get these result sets, and each batch can have one or more result sets. In the query world, each result set can be up to a gigabyte in size, and they can have up to 15 of those. You have 10,000 batches in 24-hour rolling windows, so if a job's really big, you can see how many different API calls you're going to be making. You're making tons of API calls. Each batch has its own URI for a result set, and you're going to have to retrieve that on the client side. Now with version 2, we want to throw all that away for you guys, and just get to the heart of what a query represents. So you're going to create a query job within that, just specify your query string, post it, all of a sudden the asynchronous process kicks off immediately, and then you keep pulling the state of the job, not the batches, just the overarching job. When it's complete, you can go and you go to the single results endpoint, and you can go ahead and retrieve all those results in a single endpoint. Now, obviously, we're working in like millions of records at a time, so you probably won't get it all in a single payload, but that's why we provided a pagination mechanism, which we'll talk about in the demo, so you can control and be more flexible how much data you get back. On top of that, bulk query version 2 is part of our standard REST framework, kind of what I was talking about in that table. And so with that comes a number of different things. First of all, no more X SFDC session custom header for those that have used bulk version 1. If you haven't, it's fine. You don't have to deal with it. On top of that, we support all the standard OAuth flows and authentication that comes with all the other REST APIs. Also, because it's in our standard REST framework, if you've integrated with any of our other APIs, using bulk version 2 is going to be the exact same experience, which is cool. That consistency is going to be a great developer experience. And another great thing is, for those that are familiar, we had this bulk data load jobs page. It was like a UI page that helped you manage your jobs and your batches. Now you can actually see your jobs and inspect the results through the API itself, which we'll showcase in the demo soon. So that's pretty cool. And as you can see here, this is our standard APIs that we support. So there's this notion of, oh, where did the jobs? Yeah, jobs. I guess the line is a little off, but you can see it's like 2 below. And when you open that up, you see ingest, which we went GA with. And when we go GA with query, we'll see that as well. So in the jobs endpoint, jobs query. Finally, we're going to be talking about limits management. So I mentioned before this notion of, see that batch on the left, it could have 6 result sets. The next one could have 3. But we have metered you based on batches. So you're actually going to get counted equally against your limits for the left one and the middle one. And it's not really representative of how much data you're actually using. And because of that, it's just not a consistent experience. We're trying to move toward a more, one that you guys could understand and is a little fairer, which is a records-based one. We're in pilot phase currently, and we'd love to get feedback on your current understanding and expectations that come with limits, and we can go from there as well. And like I mentioned before, pagination support. Alrighty, so with that, let's get into a demo of query version 2.0 and that experience. Alrighty, so here I got something called a Jupyter Notebook. So I've written a client in Python, and what's cool about Jupyter Notebooks is that I have a script that's basically just making all the different REST requests for query, but you can actually chunk up your script into different steps, and then you have a little documentation to kind of like walk through what each step means. So I'll actually execute this script steps at a time, and we can inspect the results of each one. So first and foremost, just want to import some Python packages that allow me to make REST requests. So I'll go ahead and execute that. Then now we want to do authentication. So no more X SFDC session header. We'll use the standard authentication bearer tokens that you're familiar with if you've developed on the platform. And I've already gotten the session ID for my org already, so didn't want to waste your time there. And we'll put that in the header. After that, we're going ahead and submit our query job. We're going to create one. And like I mentioned before, there's no notion of batches anymore. We just got a single JSON string, and we have two operations. Operation query. You can also have query all. Query all means you can query for data, records that have been deleted in your organization. But in this case, let's just keep it at the ones that are active. And then a query string. I just want to get all the IDs in our org. The headers, content type, application JSON. As you can see on the right, we have the same session ID we're passing through. And then we'll do a post on this version 46 jobs query endpoint. That's the new endpoint. Go ahead and execute that. We'll get a 200 status code and then some more information about our job. First of all, the state is already marked upload complete. The asynchronous process is kicking off as I'm talking right now. And we got the job ID right here, the operation, and a little more information that you need. So then from that, if you want to inspect and pull the job status, you just Now we'll just go to the next URI. We'll just take this job ID right here, and we'll just check the progress of this job. Same endpoint, version 46, jobs query. And now in this case, let's just do a get on the job ID endpoint. So we get a 200 status code, and this is a little more information about the job than the first response we got. This is going to have how long it took to process. As you can see, the state is job complete, which means we can actually retrieve the results at this point. It also shows us the total number of records in the job, so you can understand how big was this job operation, which will help you down the road when you're actually retrieving the results and want to do pagination, to understand how much data are you expecting to get back based on your connection. So at this point, let's go ahead and retrieve some results. If I just go to the results endpoint, and I mentioned pagination earlier, if you don't specify any pagination arguments, we're going to send you a certain amount based on the server-side logic of data. And it may or may not be all your data, depending on the size of the job. So we go to the results endpoint. Let me change the job ID here. And let's do a get. You just do /results. OK? I've also printed out the headers so that we can talk about pagination. That's going to be driven by the response headers. So as you can see here, I get all the IDs back. It's about 3,000. And so 2 important headers to keep in mind. We have this Salesforce locator and this Salesforce number of records. The Salesforce number of records is the server-side understanding of how much data I'm sending you. Now, if you on the client side do the math and you realize, oh, I didn't get as many records as the header said, that's where pagination could come into play. Not only to get more data, but maybe to even get less. So let's say I was on a slower connection and 3,000 was too much, right? Oh, and also, the Salesforce locator just shows you whether there's more data. Either this request sent you everything, and if it didn't, and there's more to paginate through, then that value will be populated. And you can return that in your subsequent response to continue with the data. So let's just say this was too much data. There's this notion of a max records pagination parameter. And like I said, we had like 3,000 records in the org. Let's just limit it to 1,000 at the time. So if I want to just get 1,000, I could just add to the results endpoint max records 1,000. And we're starting at the beginning. So if I go ahead and do, got to update the job ID. So now, the headers are going to change, right? Because we know we're only specifying 1,000 at a time. Now the locator comes into play. So the server says, you asked for 1,000, here are 1,000. Now the locator says, okay, the next record to retrieve is at the 1,000 byte mark. So as a client, I could just grab that and feed that into my next call. Let me change this again. Results, locator 1,000. And you can specify and max records as 1,000 if you want. We go through here. But since I didn't specify max records, I'm just going to get the next 2,000 rows. So we get all the data. Eventually, the locator is null, and this is the remaining data. So you have that type of flexibility. Finally, if you want to delete a job, so we store these jobs for 7 days. But if you wanted to delete it, you can just go to that specific job ID endpoint. Go ahead and just do a HTTP delete. You get a 204, and the job's deleted. And then finally, I was talking about in the presentation about being able to query the jobs in your org rather than just going through a UI page. And so how you do that is you just go to the root resource /query, just do a get, and you can see all the jobs in your org. I was doing a couple demo runs before this, so you can see there's a number of different records. And I think the last one was, in fact, it doesn't really matter. But here they are. That's pretty cool. All right. So there you go. And then
What did you say that you were running that from? Because it looked like you could do the same thing with Workbench.
yeah, there are different clients and different ways that you could just make a REST call. And so in this case, I just wanted to use Jupyter Notebooks so that we could walk through that. Yeah, just so that it's already step by step. I don't have to create the requests on the fly. And also, we're going to save time for Q&A at the end. And you can just go up to the mic and ask those questions as well. I just want to make sure we have enough time. So after that, Leo, you'll take it away about mass operations.
Thanks, Iman.
Yeah.
And thank you guys for being over here on the sunny Thursday morning, spending an hour with us talking about APIs. So as Iman briefly alluded, Salesforce has a very large variety of APIs. They're REST, SOAP, bulk, and used for different purposes. Some of them operate on one record, some of them operate on multiple records. What I'm here to talk to you guys about today is what we call a mass operations API. So the idea behind mass operations API is that there are several use cases that require you to query for some data, for some records, then perform the same type of template, same type of operation across all those records that you get back. Maybe it's, update a checkbox across all those records. Or some of the use cases that we have is a vanilla change owner on all the records that you get. So which really requires you to grab a record, update the owner ID field, and re-upload the record back into the system. The other use case could be I'm a manager and I want to create a follow-up task for every single owner of the account whose last activity was 30 days ago or later, just to be like, hey, follow up, make sure things are okay. And it's the same way. It's you grab a bunch of records, you grab the ID of those records, you create a task that you assign to the owner of the account, you make a what ID to point to the account ID that you grabbed it from, and you create those tasks. Some other use cases is I'm building a campaign and I want to add a bunch of contacts or leads to a specific campaign. Or I'm a sales rep and I'm about to have an important meeting with my boss, talk about what our profits are going to be this quarter, and I need to really quickly update a bunch of opportunity statuses to be closed won so it properly affects my pipeline and my predictions. Or the one that's a simple use case is, give everybody who attended this session on DX a badge. So with that in mind, let's maybe look at one of the use cases and how would you potentially try to accomplish it right now. So let's take a use case of I have a sales rep who's about to leave on sabbatical, and I want to reassign all the accounts to a different owner, so make sure that nothing gets dropped, if there's any chatter threads that come up on that account, if there's any follow-ups that needs to do, that somebody's actually there following it through. So you can accomplish it in several different ways with several different APIs in Salesforce, but it would include something like you do a query to get the list of all the accounts. Okay, that seems pretty straightforward. What do you do now with those results? You can maybe get the results of this query, put them all in the CSV formats, update the owner ID field for all those accounts, and then use bulk API to load them in. You can maybe do SOAP API. You do a SOAP query, manipulate all the XML objects in there, update owner ID, and kind of do the same thing. Or you can do the same thing with REST API. So seems pretty straightforward. But once we dive into a little bit into details, what that requires. Well, first, you also have to worry about what if my query did not return me all the records in one swoop, because we have a query locator concept where if you have more than 2,000 records, you have to use the query locator to paginate to get more results. You have to handle it on your client somehow. The other one is for SOAP and REST requests, we can process up to a certain number of records at a time. So you also on the client side, before sending a request, have to figure out, okay, if this REST endpoint accepts only 10 records, it means I have to chunk up all my data in 10 records each and send each request with 10 records each at a time, which is also quite a hassle. Then what do you do with the results once you get the processing? Eventually, you'd want to look at the results, see what went wrong, what potentially good, what's bad, kind of do some analysis. So you have to store those records somewhere and then pull them up for processing. So something as simple as this could actually be not as trivial and not as easy. But we think it should be. Here comes mass operations. So let's take a look at this. So on the left side, you have what the mass operations request looks like. You also have similar, step one, you'll have a query that says, select ID name from account where owner ID is whatever owner is. Then you're trying to figure out which API to use to do the following updates. In this case, we're using what we call composite as objects API. As Iman briefly mentioned earlier, composite as objects API allows us to manipulate up to 200 records in one go. Similar to, like we have SOAP that allows you to create 200 records at a time. That's meant to bring the parity between SOAP and REST APIs. So we figured out, okay, we want to use the composite as objects API to actually update all the records once we get them. And then we need to provide a template definition, which tells us internally on what you want to do with each one of the records that you get from the query. So in this case, the template definition really just corresponds to, I want to get a record, I want to get an ID of this record, and I want to update an owner ID field of this record to be a new owner, and I'm just going to send it in. In this case, we also update in a description field, just because. There's also a notification option here, notification field here, which we'll touch up on a little later, and the chunk size. And the chunk size, that's the mechanism for us to chunk up the data for you. And so in this case, you avoid all the hassle of doing query more, because we'll take care of that on the back end. You avoid all the hassle of chunking up the data, saying, in this case, the API that we call can process up to 200 records at a time. So we're saying, hey, 200 records, that's what you can process. This is go a little deeper under the hood to see how our kind of expansion works. So the right side is the side that you send to us, and the left side is the side that we actually send on the server side and do the processing. So under the hood, we're leveraging our APIs has been already well tested, composite of subjects API in this case. And so if you see blue color is effectively in the initial request that defines the REST endpoint that we execute. So all that information from that just transfers directly into the request that we make on the server side. Then yellow color is a chunk definition. And orange is some of the properties that we introduce as a part of it that helps us internally tell us how to expand the given template that you provide us. So in this case, we want to expand it as an array. And if you see the left side, on the left side, the yellow, after the expansion, you have multiple objects that are yellow. And so effectively, each one of them, we grab the data from the query and populate it and can expand them one at a time, one at a time, one at a time. And so that ends up being the request that's being sent. That's a synchronous version of it. So you send it, you get the response back immediately, or not immediately. You wait for it to be processed and to be done, and then you get response back. As we talked about earlier, there's always a question of scale. And so how do we, when you have a large org that has large number of records, and you don't want your client to wait there for all the records to be processed, what can we do? So to help with that, we also provide you an asynchronous version of it. So if you have more than 2,000 records that you want to process, or if maybe you have an org that has a bunch of triggers, validation rules, some logic that takes up a lot of time to process, and you want to return response back to the client and let it do processing, asynchronous version is a good way for you to go. The mechanism behind asynchronous version and how it works is similar to how bulk API works, Iman showed earlier. So you do a post, providing the job definitions, which are the same in synchronous and asynchronous world. Asynchronous world has a little extra parameter, we'll touch up on it later, that you can add on to it. But effectively, it can be the same. Once you post a job, you get a job ID back. You can keep doing polling on the job ID to see what the status of the job is. And once the job is completed, you can go to job ID results and retrieve the results. And we also provide a pretty basic pagination mechanism that in the response, you'll get the next result set URL that you can click onto to get to the next set of results. The optional parameter that we provide here is notifications. Right now, it's only applicable for Lightning experience. And so what it does is once job is finished, we'll send you a notification inside your bell icon in the Lightning experience that says, hey, job complete, come check it out. So with that said, maybe let's try to do the demo. Wrong buttons. So I'll be using the same Jupyter notebook as Iman used, just for consistent experience. So also download a couple of things, authenticate into the org. So first we'll do a walkthrough asynchronous version. So I have an org that has a couple of users, and I'm trying to transfer some of the accounts from one user to another one. I'm specifying the limit 5 here. So query definition is to select ID name from account where owner ID equal to owner. And I'm specifying a limit clause to 5 here, just so the response that we get back doesn't overflow the whole entire page and makes me scroll far. So in pretty much the same, so you have your job definition, chunk template definition. So let's execute it. Synchronous, everything goes through, you get the response back. You get the response back status 200, and then you have the body of the response that tells you, okay, this are the records. So you have 1 account, 2 account, 3 account, 4 account, 5 account. Notice how each one of them has a separate so mass response has an array of multiple objects, and each object corresponds to a chunk of data that was submitted. And if you notice above, we specified chunk size to be 3, and we return only 5 records, so it's effectively we're going to get 2 chunks back. One of them has 3 records, the other one has 2 records. So now, if we hit a case where we want to use an asynchronous API, which should be the same way, so like submitting exactly the same job, except you'll get a job ID back. So let's go here, let's put a limit, we'll remove a limit over here, just to see what happens. It does the processing, so same paradigm as in bulk, you get a job ID back. Now let's go and see the job details, see what's happening there. Tells us that there's total, we created 15 chunks. It's processing right now, and it'll give us some stats as the job goes through processing. It'll populate some stats on how long it took and how many chunks totally processed. We'll also have an option to see all asynchronous jobs that we have. Similar page. So right now, we also played around it, so you have 9 jobs in this case. One of them is processing a bunch of the jobs that have been completed. And once the job gets to a complete state, we can go ahead and see some of the results to see what happened. So let's see if this is completed yet. Job is completed. Now let's look at the results. So the response is exactly the same way as you would get in an asynchronous version, except you have just multiple pages of these responses. And so you see all the accounts that we got, all the transferred, and so on and so forth. Now let's also check, I believe we provided some notification information, and if we log, so since I'm the owner who submitted the job, I log into the org, I see this bell icon that says, hey, this job has completed. So that is it for mass operations. Would be really interesting to know, for us the interesting part is the template and what the APIs they're exposed with this template. So it would be interesting to know, like, what do you guys think are the useful APIs that we can use inside this templates? And I'll pass on the flow back to Iman.
Thank you.
Thanks.
All right, just a couple more slides. We showcased Query version 2 in bulk, and we're going to take that GA in the coming releases. We'd also love some of your feedback on some of the things we were mentioning earlier. Also, how do we move mass operations, which Leo just talked about, inside the same bulk framework? So we can even work with much more data at scale and a consistent experience with bulk. We want a common notification pattern across APIs. We showed a little bit about the bell icon earlier. Now we're trying to expand on that further for even more notification mechanisms. Having also a mass async monitoring page, similar to the bulk data load jobs UI page in the setup, if you guys are familiar with it. Select all field support, so that for those that aren't familiar, we don't support that currently. Getting all the fields on an entity we think would be really cool, and I think developers have been asking for that for a long time. And then a generic clone API that we're able to clone an entity and potentially its children. We're also very excited for that. That's currently in the works. So just final recap before we get into questions. We kind of had a quick review of the APIs. We talked about scale, the different flavors of the APIs, bulk API version 1, what we're trying to improve your experience with version 2. We talked about query, went through a demo. We did mass operations and went through a demo with that as well. And talked about what's on our roadmap next. So we got 5 minutes and 20 seconds. So kind of let's go ahead with questions, and perfect. You go right up to the mic. Mic check, 1, 2, 1, 2.
It might not. Oh, too far away. So what are the limits going to be for the number of rows?
Oh, in query? Yeah, so we're still trying to get to what's a good number, but right now it's in the billions. B. Yeah.
So a couple quick questions. Curious about what the query time limit is for running queries, if there's a certain timeout for those.
So he had asked what was the query timeout limit. Is that you've integrated with bulk version 1? Is that why you ask?
Yeah.
And so you guys, for those that know, we have a query timeout limit for how long the query processing takes. And so we introduced this notion of PK chunking, which you probably are also familiar with, which is breaking that query operation down into smaller units of work so that we can parallel process that query and not run into these timeout issues anymore. And so with version 2, we wanted to provide all those same benefits, but do it under the hood, just kind of like we were talking about with batches. So we know what we can do similar work with on that, and if we're able to chunk up a query into that type of work, we don't want you to have to explicitly know what's timing out and what's not. So we got that taken care of.
Okay, and one other thing I was wondering, kind of similar, is there any way to upload, if you're doing CRUD operations, is there any way to upload in multiple pages?
Upload in multiple pages. So
if
can you
you
talk
have
a little bit more about that?
large number of
Ingest, on the ingest side?
Yes.
Okay. And you want to upload multiple pages. So you're talking about version 1, there was a notion of multiple batches
Right,
you had to
basically
upload.
multiple batches.
Right?
Yeah.
Have you integrated with bulk version 2 at all?
No.
Ingest? Yeah, so bulk version 2 ingest takes exactly that idea. You upload a single file, we'll chunk it on our end.
Okay,
No
great.
need to deal with batches, yeah. And a single result endpoint, yeah.
Thank you.
Yep.
For the mass operations, is there, first question, does that work with relationship queries and relationship fields off of the original object?
Not yet. That's our next step. Right now,
Okay.
it's just the plain, simple queries.
And then would there ever be any other way to include like dynamic values, or would everything else other than those fields have to be static?
Dynamic, can you elaborate a little bit? What do you mean by
Like
dynamic?
you're just setting the owner ID as that static ID. Is there any other way to pull in something more dynamic?
So
it's not like the
one
description.
example as we're talking about in this case is if you can get this as a part of the query, then you could. Like for example,
Yeah.
for the case of creating a task for all the owners of the accounts whose last activity date was less than 30 days,
Yeah.
you'll pull in an owner ID, you'll pull in an account ID from the initial query, and then we can use that information to populate in the following chunk
Sure.
template.
And one last question. Is there any update for data loader with bulk API v2 and mass operations?
So that is currently being looked at and considered and worked on.
Cool.
Okay, data loader was my first question.
Okay.
I'm with an SI partner, and we're on a project where we inherited a mobile app that is currently syncing very, very inefficiently through an old version of the iOS mobile SDK. Do you have any strong feelings about whether it's a good idea to use bulk 2.0 from a mobile application so that we don't have to worry about a large number of acknowledgements? We can just like, even if it's just a few hundred records, like post them, poll, get a response, instead of a pattern of maybe having issues with a lot of missing acknowledgements during bad mobile data conditions.
What API are you guys leveraging?
Right now we're leveraging through an app a previous partner wrote. They're using a 3-year-old version of the mobile SDK for iOS, which currently does REST API calls one at a time in the Smart Sync framework. And volumes of records per sync have started to go up into the hundreds or thousands.
Sure. So mobile is something outside of our scope, but in terms of what API calls you could leverage, we were talking about composite. We talked about bringing REST in parity with SOAP, right? Working with 200 records. The thing is, with bulk, we're able to perform it upon millions of records, so there's not really a SLA that you could count on for that type of data, and we generally don't recommend working in the hundreds to use bulk. It's kind of not the best use case. But if you're working with records at a time, we already kind of showcased that now there are systems that allow you to send, in a REST request, hundreds of records.
Yeah, I mainly ask because the asynchronous nature is what's appealing. It's that there's a lot of triggers, processes, et cetera, going on in the background. So the longer that the app is spending waiting for an acknowledgement of a synchronous transaction, the more likelihood it gets interrupted by bad data conditions, and then we get like a duplicate insert or something like that.
Sure, sure. Well, I mean, if you're talking about latency as well, once again, I just wouldn't point you to bulk for that
Okay.
use case.
Good to know. Thanks.
Yeah, thank you.
Similar question along those lines. Did you guys improve any like error handling, or what happens if you get a bad record during the processing?
Oh, we just ran out of time. We're gonna go in the corner, and you guys could ask as many questions as you'd like.
We just wanna clear
Thank you
up
so much for coming, guys.
Excellent.
Bad one.
Ah.